The quotient rule lets us take the derivative of a fraction, or one function divided by another. It says that if you have some function f of x, we will call this the first function, divided by a second function g of x. The derivative is equal to the derivative of the first function times the second function, minus the first function, multiplied by the derivative of the second function, all divided by the second function squared. For this first example, let's find the derivative of y equals 5x divided by 2x squared minus 1. We will let the first function f of x be the numerator, 5x, and the second function g of x can be the denominator, 2x squared minus 1. Recalling the quotient rule, we get that the derivative is equal to the derivative of the first function times the second function, minus the first function, multiplied by the derivative of the second function, divided by the second function squared. So we have y prime is equal to 5 times 2x squared minus 1, minus 5x times by 4x, all divided by 2x squared minus 1 squared. Simplifying, we get 10x squared minus 5 divided by 20x squared, all divided by 2x minus 1 squared, which will further simplify into minus 10x squared minus 5 divided by 2x minus 1 squared. So our final answer is minus 5 multiplied by 2x plus 1, all divided by 2x squared minus 1 all squared. For this next problem, let's find the derivative of y equals x squared plus 3x plus 2 all divided by x plus 1. Starting off, let's let f of x equal the numerator, and g of x can equal the denominator, as per usual. So to take the derivative of y, we'll need to use the quotient rule. We get the derivative of y is equal to the derivative of f of x, which is 2x plus 3, multiplied by g of x, minus f of x, multiplied by the derivative of g of x, which is just 1, all divided by g of x squared. Simplifying, we have this equals 2x squared plus 5x plus 3, minus x squared plus 3x plus 2, all divided by x plus 1 squared, which further simplifies into x squared plus 2x plus 1, all divided by x plus 1 squared. Noticing that x squared plus 2x plus 1 equals x plus 1 squared, we can further simplify this into our final answer, which is just 1. This next problem is a bit trickier. We need to find the derivative for y equals e to the x multiplied by x minus 1 all divided by x plus 1. Recalling the quotient rule, we can define our f of x and g of x. First, let's let our first function f of x equal e to the power of x multiplied by x minus 1, and the second function g of x can just be x plus 1. However, we see that our first function f of x could be made up of two functions. Since we know we need to find the derivative of f of x, let's make this problem a bit cleaner by first writing out the derivative of f of x. So we will use the product rule. Thus the derivative of f of x is equal to the derivative of e of x, multiplied by x minus 1 plus e to the x multiplied by the derivative of x minus 1, which simplifies into e to the power of x multiplied by x minus 1 plus 1, or just e to the power of x multiplied by x. Now, let's find the derivative of y. Using the quotient rule, we start by taking the derivative of f of x multiplied by g of x minus f of x multiplied by the derivative of g of x, all divided by g of x squared. Simplifying, we have e to the power of x multiplied by x squared plus e to the power of x multiplied by x minus e to the power of x multiplied by x plus e to the x, all divided by x plus 1 squared, which further simplifies into our final answer, which is just e to the power of x multiplied by x squared plus 1, all divided by x plus 1 squared.